right, the session is live and I see some heads up, folks joining us in. Everyone, thanks for joining. Maybe wait a couple more seconds, let some more people tune in from other sessions, fluid spaces, and then we'll begin. Hello, Esther. Hey, Mariana. I hope I'm getting that name correctly. I'm Harshit. I'm joining in from Delhi. We have Tariq here joining in from Miami, Florida. By all means, let us know where you all are tuning in from. We'd love to know. All right, so we have one from Coral Springs, Florida, Philip. We have Mr. Kumar from Ranchi, Trianta Philos from Greece, Dane from Oregon, Chris from Cary. Perfect. I see a lot of heads popping up into this session now, and I think it's about time we get this started. All right, Jason from Seattle. Hello, Abhinash from India. Glad you could make it, Thomas from Cologne, Germany. All right, perfect. I guess it's about time we get started. So, hey everyone, I'm Harshit Paul, a product marketer at Lambda Test, and I'll be your host for this session on generative AI for software productivity, hype or hyper acceleration. This session promises a captivating insight into the impact of generative AI on software teams' productivity and efficiency. We will also separate the generative AI hype from its potential for hyper acceleration within the software industry. But before we begin, let's quickly take care of a few housekeeping items. This entire session is recorded, so in case you need to drop off at any point, you can review the entire session by heading into the schedule over the top left corner, right? We'll also be having a dedicated question and answer round towards the end of the session. So in case you have any questions while we're presenting, feel free to drop them into the chat box over the right side over the Q&A. You can also react to the entire session with the help of emojis towards the bottom of the screen. Please help to use them as you feel like and make the session interactive. And having said that, join me in welcoming our speaker, Tariq King. Tariq serves as the Vice President of Product Service Systems at EPAM, skillfully managing a portfolio that bridges software products and services, all while guiding the businesses through technology consulting. With over 15 years of experience in software engineering and testing, Tariq's journey has included pivotal roles such as Chief Scientist, Quality Head, Director of Quality Engineering, Test Architect, and now a VP. Thanks for joining us today, Tariq. Thank you so much for making time for this session, and the stage is all yours.
Thanks a lot, Harshit. Yeah, thanks to the organizers for having me. I'll just share my screen. Go ahead and do that. Hope you guys are enjoying the conference. It looks like quite a lively bunch there. All right, cool. All right, so yeah, I mean, that was a great introduction. Thanks again. I think, for the next half an hour, it'll be a little bit more of just like, hey, let's keep some things real. There's always a lot of excitement whenever we talk about AI and its application in software. It's exciting technology, but at the same time, I always like to tell people, like, we have to keep a level head as we move forward with any new technology, and especially coming from a quality and a testing background. And I'll focus a little bit on testing today as well throughout the presentation, is even more important, right? To make sure we get this technology right and keep it, I guess, positioned in a great place. All right, so generative AI, and there's been a lot of advances, right? And nowadays, this term has been pulled towards large language models, and it's kind of been equivalently used across that board, that when people are talking about generative AI, they're talking about some sort of NLP or text-based generation, using even more specific, using like a transformer-based architecture. But again, there was a lot even before the chat GPT revolution, and that we should keep in perspective. And so the first thing is just understanding, like, when we speak about Gen AI, at least in this context, we're talking about the technology that is behind not just creating these natural language, aspects of communication, but also generating images and videos and doing all these things in really what is a highly automated way, right, with little to no human intervention. So we're seeing AI being able to generate photos, compose music, write poems and articles. All this is under the umbrella of generative AI. And unlike most people think, a lot of this stuff actually isn't new, right? And we'll talk about kind of why I feel it's positioned right now in a great place. But understand that, for a lot of us that have been in this space, this technology has been around, and now it's kind of just at everyone's fingertips, right? So in a nutshell here, like, we're getting better and better at allowing computers to actually fool humans into thinking that they're humans and not computers. But one of my favorite topics that I like to hit off with is the idea of the generative adversarial network, or GANs. Again, generative AI creates things, right? And there's normally two branches of this. There's generative AI, which we've mentioned before, and discriminative AI. And, for example, here, when we start thinking about things like image generation, you can have a GAN that's set up to be able to create very realistic yet fake photos of human faces. And I always thought this was pretty cool technology. But what you would do is that you would pass those generated photos to a discriminator, right? Some model that's now going to say, hey, I can detect these fakes. And in doing that, what you're basically doing is now saying, hey, there's a model that's very good at generating fakes. There's a model that's good at detecting and discriminating against what is fake and what is real. And let's have these two operate in tandem and be able to use the output of the discriminator to actually improve the generation. So the better I get at detecting fakes, I can now say, hey, I can detect that this is a fake, because of this, and feed that into the generator to make it better. So the exercise is really about training both of these models. They learn to get better at their respective tasks, and the results are pretty impressive, right? And a lot of the technology that we see being applied, again, in this space is mind-boggling, right? Like, these are all pictures of people that don't actually exist, right? They were created by a GAN. And later on this year, I'll be talking a little bit about this in combination with the next topic on our list, which is the generative pre-trained transformers, which are, how these machines are moving towards a place where we actually can't tell, the difference anymore. All right, so another foundational aspect of generative AI is this idea of the GPT, or generative pre-trained transformers. In general, the transformer architecture kind of brought a lot of improvements to the NLP space, similar to how convolutional neural networks transformed the image space. And this is what we're really seeing. But the idea here, and this is not anything that is kind of new and exciting to people, but it very much was once we saw this chatbot come on the scene. As I mentioned, folks were using GPT before, especially GPT-3 models, again, more probably in startup and innovation capacities, or if you were embedded in the AI world. But ChatGPT brought it into everyone's home, right? And people could finally start to just interact with AI. And they've always been asking to see the AI and what does it do? What can it do? And, admittedly so, it's kind of exciting once we first start using it. And then you get a little bit more familiar and it's still exciting, but you start to see where there are some weaknesses, right? So ChatGPT in itself is just a specialized version of what is the GPT-3 architecture. And, more importantly now with the plus version, GPT-4. But the whole idea here is that there's this large language model and an architecture behind it. And it's very good at generating natural language. And it really has moved the state of the art in NLP, right? So NLP, again, libraries have all been out there to do different things, whether it be generating text or translating or summarizing. But these models have improved each of these things tremendously, as you probably already know from interacting with them. And while I think this is phenomenal and amazing in itself to raise the state of the art of NLP, I think to me, what was the most amazing thing about ChatGPT was that it made, I call it believable AI, just a term that I coined. And that's from my time, especially at Test AI, interacting with folks. They always wanted to kind of see the AI or experience it or touch it, or I don't know what they wanted to do. But they wanted it in their hands, and they wanted us to, when we were demoing, they weren't just happy that it did what it was supposed to do, which was a leap above the current state of the art. They really wanted to get into like how the AI works, or actually see and play around with it. And this is what I think ChatGPT has done for us. It kind of, and of course there's still skeptics, but it really made AI very visible, very comprehensible, and very usable, right at our fingertips. All right, so we're living in the age of generative AI. And again, I don't think that's news to anyone. We're seeing it all around us. But the focus of this conversation is around productivity. And I think almost every person that has used this technology, and especially those in the tech world, have been asking this question, right? Can we leverage generative AI to actually improve productivity? And, I also add a bit of caution on this topic right here as well, because I think immediately when I start talking to people and they start going into what they would like to try, sometimes it's less of can we leverage this to improve productivity and how, right? In other words, there's an assumption that productivity will improve, right? And I always warn people against this, which is really confirmation bias, right? Like once you have, some favorable point of view, you try to then confirm, your thoughts and your strength. And it's very hard to actually get you to go back on that. So I always challenge people to say like, hey, let's make sure that we look at this objectively, because otherwise you could just be, no matter what your result is, you could just be trying to feed whatever assumptions you have. But there's a lot there. So that's one caution as well. But in just looking at this, whether or not you actually see gains in productivity will depend on the context of what you're doing. And also that bigger picture, right? Like you might improve productivity over here, but what does it do overall? And even just taking a step back on all of this, like what do we mean when we actually say productivity? It's not a trivial term, number one, to decompose, and it must be clearly defined, right? So I think part of this was for us to kind of look at productivity and then put it in the context of this, technology. So one of the things that I always remember, there was a point in time when I was at an organization and they were talking about going faster, right? Accelerating and going faster. And they were talking about testing, especially being a bottleneck, and we needed to go faster, but we need to go faster and somehow maintain the same levels of quality, right? Because it makes no sense to produce the wrong thing fast, you're still not going to succeed, right? And from that time, I always position productivity into these three buckets. It's the intersection of what is quantity, quality, as well as efficiency, right? Because it is about throughput and how many tasks you're getting done, but they have to be finished to a certain level or a certain standard of quality. And then that quality that you achieve and that quantity can't cost you so much that it's not practical anymore, right? Or you can't be just, wasting a lot in the process as you go through it, right? So it's important to understand like that these three things are at play. And when we start talking about improving productivity, you have to be wary again of looking at only one dimension of these things instead of all three. And, this follows off from, I think, a topic that I spoke about earlier this year, which is force multipliers. I gave a keynote in Cologne, Germany, for the person who's on here from Cologne, beautiful city. But it is, and people look at that, well, okay, of course, like if we, if we have like a tool or something, like we can do more faster, et cetera, et cetera. And they kind of trivialize this idea of force multiplication, but really it's a compound effect. It's more than just the person in the chair. It's more than just the tools behind them. And it's more than even, I talk about the coffee cup there being a force multiplier, because it has a lot to do with different aspects of culture, not necessarily coffee. The coffee thing was an analogy for like Cuban coffee breaks that we would have at Ultimate Software when I was there. So there's a lot behind that. And I tell people, like, okay, start thinking about where we're going with this technology. And we talk about GitHub Copilot, right? So of course, once we started seeing AI, again, seeing believable, seeing AI generating code, and it's like, oh, wow, like AI can maybe replace some of the tasks that developers are doing or enhance it. And, back in, I think, September or so of 2022, they did this survey based on the experience of 2,000 plus developers. And you can see some of the numbers there in terms of like their perception on productivity increases and, in terms of the duration of time, right? So 1 hour and 11 minutes versus 2 hours and 41 minutes, right? So it looks like a 2x increase, right? And again, nothing against the survey. I encourage you to go check out. I put the source in there. But there's certain factors that study did not consider, right? Like team composition, the intricacy of the task itself. It was not a production level project, right? And so when you look at these things, again, any level of study or experimentation, please put it in context and understand that there's threats to the validity of the study itself and any claims that you make moving out from there. And again, this is not against that study. They didn't make any claims that weren't there, but someone taking this information and then trying to say, hey, I should expect to see this in my own production project that doesn't fit this mold, would find themselves highly disappointed in this thing. And then another good point to note here as well is just that, for example, in an organization that may be already riddled with a very large and complicated code base that they're having a hard time managing and maintaining, even increasing productivity at this point may not help overall, right? It might just make a bad problem worse, right? Now we have more code even faster that we can't manage and maintain because the rest of the organization either is not ready to consume it. So all those things are important to put in context. And I lead it into the fact that generative AI has potential benefits. There's no doubt. When you look at the technology, you can see it, right? When you watch it writing code and stuff like that, it actually looks very impressive. But it actually also comes with a number of challenges. And so first one that always pops on the top of people's minds is like security and intellectual property, especially if you're talking about something like Copilot or whether or not the model was trained on, data that, could have been to some degree the IP of someone else, right? Like who actually owns this at the end of the day. Security and privacy goes without saying that as a major concern. The other thing is recognizing that, okay, as with any tool or technology, like there's some level of upskilling to make sure that folks know how to use it and use it correctly. In particular with large language models, the wrong result for sure. If you ask the wrong question, you will get the wrong answer. But in some cases, you ask the right question and you still get the wrong answer, right? And so these models can hallucinate. And how do you start dealing with that? How do you fit that into the overall thing and the impact on productivity? Because the fact is that these tools spit out, and they can spit out a lot of information quickly. And to the untrained eye, it may not be apparent that this thing is wrong, right? And so I always recommend people to start leveraging these models and getting familiar with them in a domain that they understand so that they can actually validate and review the output that comes out. And then the whole task of measuring productivity gains is not a trivial one. Faster doesn't just necessarily mean better, as we mentioned before. All right, so yeah, productivity, right? Like, yes, it is much more than just flow, right? The speed of delivering features. As I mentioned before, there's a lot of different things that tie into it, including the engineering culture. I remember some of the best teams that I worked on and would never have a problem working on again, were because like the culture of the organization was such that like you were committed to mission, you felt motivated, you felt appreciated, you felt really to be a whole part of something either new or novel or special. And those things are such a boost on productivity of an organization that, you know, again, AI being a great thing, you have to understand like all of these other things are in play. It's also very important to make sure that you're asking the right questions at the right time and getting those responses to keep things moving, and actually keep things aligned with the business and the customer. So we'll revisit like the you know, quantification part, but just know like, hey, if we're gonna actually use AI to improve productivity, we have to be able to measure it and quantify it and look at all the different dimensions that it represents. And so for me, like this is really the motivation for this talk. Like there's a big need for more experimentation. And this is actually like one of the things that I've been mostly excited about of recent is the fact that like I'm kind of embedded around people that are immersed in actually doing practical experiments with this technology and know how to measure it, and then encouraging others to kind of do the same, right? So EPAM has had like quite a bit of contributions to generative AI for productivity, including like surveying over 300 practitioners, actually having folks submit and share over 1,200 use cases across the software development lifecycle. And then over 30% of those have been specifically related to testing, which again is kind of like, I'll always be a testing nerd. So those things get me very excited to see. And it was actually quite amazing and yet overwhelming to see like the volume of this, right? You know, again, EPAM has 65,000 employees. So it shouldn't be surprising that this type of stuff happens, but I'd never seen stuff at that kind of scale before. And while like 400 of these are directly related to testing, like there's a whole bunch of others that are indirectly related or related to quality as opposed to testing or test automation specific. And so we'll talk about some of those. But the whole idea here, and what I try to tell people, is like the first step, in addition to understanding what productivity is having a very holistic view of how to leverage this technology across the development lifecycle, right? So it's not just GitHub Copilot and generating code, right? It is everything from requirements elicitation and analysis, right? Can I leverage things to help me generate mocks for user interfaces, right? Or do wireframing, or generate the user stories, or validate the user stories if you like testing, right? And similarly across other areas, operations, right? Infrastructure as code is just another level of code generation, right? But applied specifically to ops, support, evolution, maintenance, etc. So that's one dimension, is across the life cycle. And the other dimension is understanding that, like, yes, it can be applied within these activities that people are doing to make them in what they're doing more productive. We can also leverage it to build new tools or accelerators that help us to do more with less in the true sense or form of a force multiplier. But one, which is last here, but definitely not least, of the most important points to drive home on this is that it must start from a very sound engineering excellence standpoint, right? Like if you haven't baselined your maturity and where you're at, then getting the benefits from generative AI will probably not be there, right? So you have to actually do some of that analysis first, even before you embark on your experimentation journey. All right, so just a cool experiment to stop all the boring talk on productivity, but is one of my favorites across disciplines. So Manoj works out of London, and we had a good discussion about requirements. He's a business analyst, and he had an idea for a quick win use case scenario, right? Like, hey, could we just actually have a conversation, be recorded between a business analyst and a customer around features, and then feed that transcript right into a large language model and generate user stories, actually validate them, refine them, etc., look for missing gaps in requirements, etc., and go from there. So again, there's probably many use cases, many particular ways that you can leverage this. But I like the idea of first starting from a verbal conversation, moving all the way to acceptance criteria and acceptance tests, and even down all the way through to test automation. So that thread to me is pretty exciting. Of course, all of the testing related use cases as well are key for me. Test case development, test case design, code generation, scripts. We'll talk about some of that stuff. Using it for test planning and test case generation at a certain level. But again, once you start looking at all these use cases, I think the important thing to understand is knowing your context. Like for your organization, maybe you use particular frameworks, maybe you have a particular process, understanding what all that looks like, and then running some concrete experiments that not only try to apply this technology in some focus group that is applying it, and either compare that historically with previous baselines or baselines taken before you walk into it, and then making sure that that measurement actually occurs at multiple levels, right? Not just at the individual person or even individual task or area level, but at the team level and across the entire gambit of the development life cycle, right? So these are just examples from testing, because again, testing is my favorite, so I said it. All right. Another thing to understand or recognize is that like a lot of this, I guess because everyone has it at their fingertips and they're interacting with it in a particular way, a lot of the focus has been on things like prompt engineering, like how do I, design the prompt and guide the model towards the desired output that I would want. That has a low barrier to entry, like anyone can kind of do that almost. But it also has limits, right? Especially the size of the context that you feed to a large language model. Most of them restrict that via prompt engineering. And so like we've been applying different techniques for different tasks. Of course, prompt engineering is still in the mix, but we also been using embeddings where we vectorize the input. And that gives a much larger context, but also requires you to have a little bit more expertise. And we'll talk about what that means. And then actually fine-tuning or adapting models to specific tasks. And so the easiest way to kind of grasp what is the differences here, like prompt engineering can give you a very quick and easy way to do things like create high-level requirements or test cases, right, at that level. Again, because of limited context, it doesn't help you much if you wanted to analyze like a production log or test histories. And so for that, you might need to encode those logs so that the machine can then analyze that larger context. And then a good example from the fine-tuning or kind of adapting the model to different tasks is like, we know that these models have been trained on the internet. They might be trained on specific frameworks, but they might not be trained on your framework, right? So if you wanted to adapt it to work for your homegrown framework and generate very framework-specific code or test scripts, like you might need to now go into like a fine-tuning activity to be able to do something like that. All right, so hopefully that was clear. We can always ask questions about that later. But obviously, like a key part of this is innovating with new tools, right? These are two accelerators and tools that were built at EPAM that, again, having the pleasure to watch people innovate and actually contribute things to open source around this space is pretty cool. And in general, like I'm seeing like two categories, right? Like there's folks who are still very much tied into the the secure chat interface and being able to interact with the chat bot, and others who are focused on like, hey, if there's specific development tools, IDEs, maybe even Jira, can we actually build generative AI plugins to help enhance the software development lifecycle by extending those tools with new capabilities? So pretty cool. And last but not least, like you have to address the security concerns. Part of that can be done through the tooling that you built, and that's kind of what our approach has been, in that, yes, people have trust issues, right? But making sure that their solutions are enterprise ready and that they're on their own infrastructure, right, is important. And there are solutions for that, right? Like, Azure, OpenAI, Google's Vertex, like all these things can be deployed on your infrastructure without communication outside. And a lot of people always ask me like, hey, well, like, how can you still trust it? Like, it's Microsoft or it's Google or whatever. Like, well, like your IP is tied up in Microsoft and or Google already, right? With your docs or your presentations or all this stuff, right? So again, focus on these enterprise level things. They have a bigger reputation to try to hold on to than worrying about if your code leak from their LLM. They got bigger stuff under their belts. All right, so to wrap up, and then we'll open for questions. So just some thoughts, right? So this is about hyper acceleration, and like my whole thing for this this year is that as we go through this, like we will see that AI in itself is always going to be surrounded by hype. Like there's no escaping it. The key is that in the midst of that hype is to try to be, and this is what I try to do every single time, try to be an advocate for the things that AI is realistically capable of doing. Have things be based on a foundation of doing experiments and learning from them and using them in practice, and not just theorizing about them in your mind, right? Or what you think it would do, and not following on to any bandwagons that overstate claims and that sort of stuff. Like we've been dealing with this in the testing space for a long time when it comes to AI, overstated claims. We're still dealing with it and all that. But the more people that are getting educated and understanding this can start to draw that line between the hype and the hyper acceleration. I do believe that there's promise in hyper acceleration, and it's shown through like this slide. Like this is nothing. I've been saying this now since even maybe right before Test AI. My stint there was that like what we expect to see happen will and is continuing to happen, right? We're seeing people enhance portions of tools using this technology. We're going to see more and more full tool stacks actually get replaced, because as the AI gets smarter, as it gets better, or as it gets capable of doing what you would do, you're going to start to trust it more, and then be able to say, well, okay, it can do that, move on to the next thing, right? This is like human nature, right? Until we trust it, like we won't move on, but once it's doing it reliably, we can move on. And so eventually it'll take over many of the activities that I think that we're seeing in this space, right? And again, there's not an overnight blink, but this is the evolution that I see happening. And it's pretty exciting, to be frank, to be a part of it. So I hope you all are engaging and getting out there and joining into the experiments and so on and so forth. So, all right, with that, I'll open up the remaining time for questions.
Perfect. That was quite an engaging session and a much needed one as well. We have a lot of questions, especially since you talked about how we are overstating the impact that we can get from AI, right? So one of the questions is about setting expectations from it, right? In your experience, what are the realistic expectations for the actual acceleration that one could achieve from generative AI?
Yeah, it's a good question, right? I think to keep it very realistic, you first have to identify and look for inefficiencies in your organization or with your projects that you usually know of these things, right? Like you're like, hey, we're very slow over here in this area, or like when it comes to test documentation or manual test creation, like these things are usually very error prone, right? And again, it starts off like with saying, hey, we're going to start by trying to make improvements. We're going to use this technology as a conduit to see like if we can make improvements. And it doesn't even have to be about, the first thing is like setting realistic targets, or sometimes not even setting a target beyond improving the baseline can also help. If you say, well, I expect this to give me like a 50% improvement, or to double our output, right? Like, okay, you might be setting yourself up for failure immediately by setting such a target. Instead, I would say first set a baseline, right? And actually run through what is the experiment, or using the technology instead, and measure it and let the data tell you how well you're doing, right? So the realistic expectation is that we want to learn if this works in this context for this problem, not assuming that like it will change everything that we do and no one will need to code anymore, no one will need to test. Like these already are initially like unrealistic expectations, but even without being that extreme, setting too high of a target, you could also disappoint yourself. So we've been just running these things, measuring, and kind of looking at what we've been seeing and adding those data points to learn, right? We got to do more experimentation. Like there's a need for more. So hope that helps.
Greatly explained. So there's another great question. What's the best way to introduce AI into an engineering or say QA team?
Cool. Another great question. Best way to introduce AI. First, I would say to the QA team, or the engineering team, AI is already here. Just go play with it. And I joke about that, but I think the best way to introduce, back in the day, it was so hard to answer this question before because there wasn't much of anything that you could pull from online to show people, right? You had to actually show them some product that you were building or something. Nowadays, you can see this stuff, people can play with it, they know it's there. So that being said, I think the best way to start introducing things is to actually get a team of folks together, have a session that kind of overviews what are the different types of AI and machine learning models and how they can be applied to engineering, how they're being used, having a workshop like that first, right? So that everyone has a baseline of understanding or at least exposure. And then with that same group, having them brainstorm how it could be used for their team in their organization in their context, right? And then from there, learning from others and being part of a community. So I think it starts again internally with some baseline of education, and then moving on from there as a team, you walk forward with it together.
Right. So here's a spinner question. How do we test AI using AI and automation?
So this is actually, and if this talk were longer, I would have gone down into these paths. Testing AI, again, I think, and even testing large language models specifically, very exciting topic. Actually, Jason probably has written more on this than I have, so you can feel free to ask him. But my take on it is that you test AI in some of the same ways that you test other things. And then there's a whole new aspect of testing that needs to be uncovered to actually test AI adequately. And I say that to say it this way. There's parts of AI that are, non-adaptive. They are things that you can check ahead of time and test. We are accustomed to doing a lot of pre-deployment testing, right? So any kind of these things can still be tested using the sound or tried and true testing methodologies that we use today, right? There's another aspect of AI that's very adaptive, right? It learns at runtime. It kind of is something that you can't know if it's going to work ahead of time usually, but you have to kind of ongoing monitor it during production and test it as such, right? And this is where EPAM, we came up with this term shift left, but test right, right? So you want to test early and frequently, and these things all apply to AI as well. But you also want to have a strategy for testing that model as it is deployed in the well and being used, right? So again, this is a meta question, right? That could go in circles. How do you test the test, right? How do you test the AI that uses AI for automation? I would say, number one, only use AI where you think it should be applied. And then when you do it, take some time and some learning to figure out what are some approaches. I give some courses on quality engineering for AI and machine learning systems that are very insightful for techniques beyond data science stuff into the kind of practical real world testing experiences for AI systems. So check those out.
Great. So a lot of folks are thinking their ways of incorporating generative AIs into workflows. So are there any challenges or limitations that you encountered that you want to run through with the audience once?
Yeah, for sure. One of them I kept trying to call out up front, right? Sometimes the challenges that you're having up front are that the team or the organization actually isn't ready in certain parts, right? So if you don't have certain things together, like if you aren't measuring certain things already, you're not looking at your defect leakage or defect containment, or you're not looking at your automation stability or these things. Like if you can't even get a baseline to understand where you're at, then it will be hard to know if introducing generative AI is actually helping or not helping. So that's the first challenge, is to make sure that for whatever you're doing, that you can actually establish like a good baseline, that you are familiar with the organization and where things may be operating smoothly and where there might be challenges. The next thing beyond that is overcoming, and this is a lot of the conversations that we have started with folks up front. Quite frankly, a big challenge is, like, depending on your domain, like all those security concerns and security issues and that kind of stuff. Now, the good thing is that, like, depending on what you're talking about, normally a lot of people come to me talking about testing, and the organization is actually like a lot more comfortable starting in the testing area than starting in other parts of the organization, right? But that can also be a challenge in itself, because data privacy, security, compliance in many domains, like, and the risk, they're obviously, like, even in the scheme of things, like being risk-based is very important. So that's kind of like the major ones. Beyond that, it then just becomes more of an upskilling or training viewpoint. And it's not as challenging to me there with that. The teams are open to it as long as they have an open mind. I think they can be successful.
Right. Although you did touch upon the tools that can be used as a part of generative AI, broadly saying plugins and IDEs, but are there any favorites that you would want to pop out, maybe?
Favorites. So I don't have any specific favorites. I can say, so I've been playing around with a lot of different things as they come out. Again, some is hype and some are not. But I think keeping pace with obviously what OpenAI has been doing, keeping pace with Google's Vertex stuff is very, very cool. If you haven't ever checked it out, I'm looking to see, obviously, like Hugging Face and stuff like that. And there's now I'm looking to see Amazon's response to all of this, because I don't see AWS as much in the mix. I know there was an announcement about some Hugging Face integration into AWS. But then, like, there's a lot of little tools popping up here and there, right? Aside from the big companies, from the Azures and the infrastructure there, I've seen some of the technology around, like, and we built some local projects at EPAM around, like, chatting with files, and I think there's a lot of potential there for doing stuff in the SDLC by being able to manipulate and analyze, like, different file types and stuff like that. But yeah, I think you just got to get out there, play with the tools and technology, learn how to use the API if you're inclined to do that. If not, find your favorite chat interface and see how you can integrate into what you're doing. So.
Yeah, so we did touch upon the challenges, security being one of them, right? So here's a question: could you elaborate on strategies to ensure that the automatically generated code aligns with best practices and security standards, especially in critical applications?
Yeah, so the strategy that we've had for all of these things, whether it be Copilot or anything generating tests, is to understand that you need a human in the loop and have a good review process, right? There's no secret sauce. These models can hallucinate at any time. But what we've done is very clearly had in your process, like, hey, you generate these artifacts, like, you have a review checkpoint. Again, it should be someone that can spot these things off the bat, that something is wrong. So just review and compliance, like, there's no magic sauce there.
Right, and we're just about done with the time. So here's a fun question for you from Jason: can Gen AI replace VPs?
Probably. It depends on what you're VPing. It probably can replace MVPs too, if you want to have a play on acronyms there. But yeah, good to see Jason around, even virtually. But yeah, good stuff. It probably can replace me, as you know. Most of my function wherever I go is replaceable, but it just won't have the same wit and charm that I have. So
Yeah, I'm sure we all agree, and we find it hard to believe that you will be replaceable anytime soon, Tariq. Thank you so much for this session. This was so insightful, and I'm sure the audience loved it as well. Jason, for sure, mentioned that he has vectorized you as well in the chat box. He seemed to have mentioned that, and he says that you know the reality of all of this. So hats off, and audience loved the session as much as I did. Thank you so much for taking time out of your busy schedule for this one. I'm certain some of us have would be heading back to the drawing board in terms of how we will be using generative AI based on your inputs and experience. Also, a big thank you to everyone who joined us. In case you were not able to attend any of your questions since we are running short on time, feel free to drop them on Lambda's community. And you can also sync with Tariq on the Fluid Spaces. So after this session ends, make sure to connect with him on Fluid Spaces. And in case you join in the middle of the session, you can watch the entire recording from the beginning by heading into the schedule button over the top left. We have had tons of conversations around AI, a lot happening from day 2 and day 1. Also, there have been some sessions around AI, so you can replay them as well from the schedule. Thank you so much, everyone. Thank you, Tariq. Happy testing, and have a great day ahead.
thank you.